So we're going to continue using the converse of the Pythagorean theorem to determine if a triangle is acute, right, or obtuse. And just take these three values here as our first example. Units are, I guess, sort of arbitrary for this example. They could be centimeters, meters, whatever you wanted them to be. The first thing I like to do is ensure that these are even possible numbers. And I did a real quick video on telling whether or not three lengths of sides could make a triangle, if that's possible. I encourage you to watch that if you're not sure what I'm talking about. And that is, could 4, 9, and 7 make a triangle? Well, I like to attribute C to the longest side, and then the other two, it doesn't really matter which one's A and B. So the question is, if A plus B, or not the question, but if this statement's true, is greater than C, then we know it's a possible triangle. And in this case, of course, 4 plus 7 is greater than 9. And so we are confident then that this is a possible triangle. So now we have to kind of come to the idea or the question, what kind of triangle is it? Now that we know it is a triangle, is it acute, right, or obtuse? And in that last, there was another video just before this where we talked about the relationship between acute and obtuse. And so these are some examples to go with that. And we found that if a squared plus b squared equals c squared, then that's a right triangle. If a squared plus b squared is less than c squared, or if c squared is greater than that, we know it's obtuse. But if a squared plus b squared is greater than c squared, then we know it's acute. So in this particular case, I'm going to take those values, I'm going to square them, and I'm going to see how they relate to each other. So 4, 7, and 9, we have a, b, and c. So we have 16 plus 49, and how does that relate to 9 times 9, or 81? That would be the question. They're probably not equal, we'll find out. So 16 plus 49, we've got 65. So 65 is less than 81, so in this particular case, a squared plus b squared is less than c squared, or c squared is greater than a squared plus b squared. So we know the triangle with these sides, it's a possible triangle, and it must be obtuse. All right, let's do another one, but let's have the sides be irrational numbers, and we'll just kind of review how to deal with that. Okay, so if we were given these three side lengths and asked what kind of triangle could have these three side lengths, first we would want to determine whether or not they're possible for a triangle. And it's not a terrible idea to use a calculator to approximate these sides. If you don't have a calculator, you'll have to use your estimation skills. This comes out to about 6.7, roughly equivalent to 6.7. This one here is roughly equivalent to 3.5, I believe. Yes, 3.5. And so we know that the sum of 6.7 and 3.5 is going to be greater than 8. So these are definitely possible sides. And that's really, aside from that, we don't need these approximations other than just to confirm what the longest side is. In this case, 8 would be the longest side. So we're going to want to attribute that to C, and we can let these be A and B. Again, it's important that C is given to the longest side, or the converse of the Pythagorean theorem, and using the Pythagorean theorem won't work to answer this question. So now I'm going to not worry about using these approximations. I want to use the actual values to make sure I'm as accurate as I possibly can, and because it's in some ways going to be harder to use the decimals. So we'll use the actual values. So 3 square roots of 5 squared. And then we know we're going to add that to b squared, so 2 square roots of 3 squared. And then how does that relate to 8 squared? That becomes the question. How are those related? And I think a challenge for some of us might be remembering how to square these values. How would we go about doing that? And so I want to talk about that just for a second. Let's look just at 3 square roots of 5 squared just for a moment. How would we evaluate that? Well, we know that's equal to 3 square roots of 5 times 3 square roots of 5. And you may know that you're allowed to multiply the numbers on the outside and you're allowed to multiply the numbers on the inside. I want to talk about that for a second, though, not just take it for granted. This section right here is just 3 times the square root of 5. So this whole expression could be rewritten as 3 times the square root of 5 times 3 times the square root of 5, which is the same thing as 3 times 3 times the square root of 5 times the square root of 5. Because with multiplication, it doesn't matter what order we multiply in, it's going to come out to the same answer. 2 times 2 times 3 is the same thing as 2 times 3 times 2. And same with this. So that's how we get the 9. That's I think, pretty clear. But then what's the square root of 5 times itself? Well, that's just 5. And if you think about that for a minute, it probably will make sense if you think about what a square root means. Another thing that might help you is we can just multiply the numbers because they have the same exponent. And so 5 times 5 is 25. So the square root of 5 times the square root of 5 is just the square root of 25, which we know is 5. So they essentially are inverse operations. If you've got a square root of a perfect square, you're going to end up with a base of 5. So a lot of jargon there just to help you remember how to square these values. And that's why I think it's actually easier than working with the decimal approximations. It's not only more accurate, but we're going to end up with more whole numbers. So this is 9 times 5 plus 4 times 3. So it becomes a simple matter of, when you become fluent at this, it's just 2 times 2, and then this becomes 3, because it's the square root of 3. How does that relate then to 64, or 8 squared? So 45 plus 12, question mark 64, well, that's going to be 57. So 57 is less than 64. So in this case, a squared plus b squared, again, was less than c squared, making these dimensions, the dimensions given right here. Oop, there we go, I got it. Making the triangle of those dimensions obtuse. I'm going to do one more. And if you're a student for one of my math classes, remember these are supplemental videos. And I know I'm maybe over-explaining for some of you and possibly under-explaining for others. You can always turn these off whenever you want. So if you got it, great. If not, I'll do another example. So what if we're given these three sides, the square root of 10, 15, and 16? Well, I listed in order. We don't have to worry about approximating anything. I know this could be A, this could be B, and this is C because it's the longest. But when we square these, they just become themselves. So it's actually going to be a pretty easy one. So the square root of 10 squared plus the square root of 15 squared, how does that relate to the square root of 16 squared would be the question. And so 10 plus 15 is greater than 16. So that's 25 is greater than 16. And so because a squared plus b squared is greater than c squared, we know this must be an acute triangle. And again, if you're not sure why this is correlated to an acute triangle and why the other relationships were correlated to an obtuse triangle, you're going to want to do some research on that. And I have a video on that I made just previous to this that explains that concept and why the converse of the Pythagorean theorem can lead us to that conclusion. All right, thanks. Good luck.